Hello guys, welcome back to my lessons. Today we're going to talk about number patterns and sequences, and we'll be focusing on quadratic sequence. Remember, there is arithmetic sequence, quadratic sequence, and a geometric sequence. We talked about arithmetic sequence. Today we're going to talk about quadratic sequence. In quadratic sequence, at least 4 numbers in the sequence are needed to determine whether the sequence is quadratic or not. There is no common difference. There is a common second difference instead. So this is what I mean. This is the sequence 6, 12, 22, 36, and 54. 6 being the first term, T1, 12 being the second term, T2, 22 being the third term, T3, 36, T4, 54, T5. And what you're going to do, like we do in arithmetic sequence. The second term minus the first term, we get the answer, that is 6. The third term minus the second term, 22 minus 12, that is 10. 36 minus 22, that is 14. 54 minus 36, that is 18. And then that is called the first difference. As you can see that the numbers are not the same. So what do we do from there? What do we do is that we take the second term of the first difference, we minus the first term of the first difference. 10 minus 6, that is 4. 14 minus 10, that is 4. 18 minus 14, that is 4. So that is our second difference. So the minute you see a sequence and then you trying to find the differences and they're not the same, try to find the differences of that first difference. And then if you find the common difference, that is a quadratic sequence. So they might ask you to find the next term after 54. What are you going to do? You're going to say 54 plus 18 plus 14, and then you get the next term, which is 76. But then this might confuse you, and if maybe you want to use the easiest way, what you can do is to find the general formula of a quadratic sequence. So the general formula is going to help you to find any term that you want. They can ask you to find the 99th term. You'll be able to find it using the formula of the general formula of the quadratic sequence. So the formula is Tn is equals to an squared plus bn plus c. And then n it means number of terms, obviously. So when you see n, you substitute the number of terms that you're looking for. If you're looking for term 1, you substitute 1 at n. So what about a, b, and c? So this is what we're going to do. Look at the next slide. You're going to find the differences like this, like I did, and then after that you're going to write a plus b plus c is equals to 6 there at the first on our original sequence. A plus b plus c is equals to the first term of the original sequence that we were given, right? And then from there you're going to say 3a plus b is equals to 6 is equals to the first term of the first difference. And then the last one, 2a is equals to 4, 4 which is the first term of the second difference, right? So what you have to do now, you're going to know these things by heart. You're going to know that a plus b plus c is equals to the first term of the original sequence that we're given. And then 3a plus b is equals to the first term of what? The first difference. And then 2a is equals to 4, which is what? The first term of the second difference. And then what do we do from here? We start from the bottom. 2a is equals to 4, which is the first term of the second difference, the 4. And then to find a, we're going to divide by 2 both sides, and a is equals to 2. And then for b, now we go up, right? 3a plus b is equals to 6, 6 which is the first term of the first difference. And then you're going to substitute a since we found it already, which is 2. and then you substitute your 6, you put your 6 on the other side, and then to find b, you're going to transpose. You take the 6 on the side of b, you take it to that side, it's going to be minus 6. So 6 minus 6, that is 0. And then what you're going to do, we found b, which is 0. We're going to find c now. You say a plus b plus c is equals to 6, which is the first term of the original sequence, of the quadratic sequence. And then we already have 2, we already have b, and we're remaining with c. You substitute the a and the b, and we're left with c. And then what you do, you're going to transpose. At the end, your answer is going to be 4. C is equals to 4. And what do? You take the general formula Tn is equals to an squared plus bn plus c. You substitute. At a, we found 2. You substitute 2. It's going to be 2n squared. At b, it's 0, and 0 multiplied by n. That's going to be 0. So the b is out. If it was a number like 3, we're going to say plus 3n. But now, since it's 0, 0 multiplied by n, that is 0. So from there, we're going to say plus c. What is c? C is 4. So our general formula is going to be Tn is equals to 2n squared plus 4. So with this general formula, you can find any term that you want. For an example, if you're looking for term 2, just to prove this that you did the correct thing here, what you're going to do, you're going to substitute 3 on the n. So 3 on the n, we're looking for term 3, and then 3 squared, that is 9, and then 9 multiplied by 2, that is 18. 18 plus 4, that is going to be 22, right? So as you can see, that the third term on the quadratic sequence, that is 22. If they ask you, they want term 59, you can just substitute your n, and then you're going to find the answer. So what they can do again in quadratic sequence, since the first difference, the one with different numbers, it's forming an arithmetic sequence, they might ask you to find the sum for that arithmetic sequence, right? And then you already know how to find the sum. You learned that from the previous lesson that I made, and then you'll be able to find the sum. If they want the general formula for this arithmetic sequence that is formed, you can always do that. You've learned that from the previous lesson. So thank you so much for listening. Don't forget to subscribe to my channel, and I would really appreciate that. Thank you.